Hello, it's time for our SHS2 Mathematics program, made possible by the Center for National Distance Learning and Open Schooling, CENDLOS. My name is Betty. This is the third lesson on indices and logarithms. And our topic for today is relating indices to logarithms. Today, I hope that by the end of this lesson, you should be able to write index numbers in log form and vice versa. Can you remember what we have done in indices so far? Let's see. We learned about writing a number in index form. We learned the laws of indices, and we also learned how to use the laws to solve equations. In today's lesson, we shall relate the indices to another topic called logarithm, or log for short. A logarithm is the number or exponent to which a number must be raised in order to get some other number. I want us to refresh our minds on the following things we learned in indices. For instance, we learned that 100 can be written as 10 raised to the power 2. And remember, when we write it like that, the 10 is the base and the 2 is the exponent or the index. This statement can be written in logarithmic form or in log as the log to the base 10 of 100 is equal to 2. It can also be written as log base 10 of 100 is equal to 2. You will notice that the 10 is written very small. In indices, the base is the big number, but in logs, the base is rather the very small number. Again, 1000 is equal to 10 raised to the power 3. This means that 1000 is the same as base 10 with an exponent of 3. This statement can be written in log form as the log to the base 10 of 1000 is equal to 3. Again, we can write this as log base 10 of 1000 is equal to 3. Again, you can see that the 10, which is the base, is written very small. Now, can you try this? We have 10,000 is equal to 10 raised to the power 4. This means 10,000 is the same as the base 10 with an exponent 4. We can write this in log form as the log to the base 10 of 10,000 is equal to 4. And in short form, we write log base 10 of 10,000 is equal to 4. You can see that base, which is 10, is written very small. I hope you are getting it. Now, what can you say about this? If you have 100,000 to be equal to 10 raised to the power 5, can you write it in log form? We will write log base 10 because the base is 10 of the number, which is 100,000, is equal to the exponent, which is 5. So we say log to the base 10 of 100,000 is equal to 5. I'm sure you can see the short form of writing that statement. Good. Now, we want to relate this to log in other bases. So we want to look at 8, which is written as 2 raised to the power 3. We can write this in log form. So what do we write? We write log. The base in the indices becomes a very small number beside the log. So you have log base 2. The number is 8, and your answer is 3. So you have log base 2 of 8 is equal to 3. Again, 81 is equal to 3 raised to the power x. We want to write that in log form. So we write log, our base should be 3. So log base 3 of the number which is 81 is equal to the exponent which is x. So log base 3 of 81 is equal to x. Once again, y is equal to 9 raised to the power 2. If you want to change that to log form, you write log base 9 of y, and it should be equal to 2. So log to the base 9 of y is equal to 2. 625 is equal to 5 raised to the power 4. Change that to log form. You write your log. The base is 5. The number is 625, and that should be equal to 4. So we have log base 5 of 625 is equal to 4. Once again, we have 121 is equal to 11 raised to the power 2. In log form, we write log. Our base is 11, so the 11 will be written very small. The number is 121, and the answer should be the exponent, which is 2. So log base 11 of 121 is equal to 2. How about the next one? 64 is equal to 4 raised to the power 3. I'm sure by now you can write it. You write log. The base in that question is 4. So log base 4. The 4 must be written very small beside your log. The number is 64, and it should be equal to 3. So you see, it's so easy to change from indices to log. Now that we can write an index number in log form, let's change from log form to index form. Again, this is very simple. Now, from our last 2 examples, we want to reverse the results from log form to index form. So let's look at log base 4 of 64 is equal to 3. We want to change it to indices. The number we are talking about is 64. So we are saying that 64 is equal to the base, which is 4, to the power 3. So that small number now becomes the big base in your indices. Again, we have log base 11 of 121 to be equal to 2. We want to change it back. So our number is 121. This will be equal to the base, which is 11 raised to the power of 2. That's simple, isn't it? Now, let's try these. And I hope as we go along, you'll be writing on your paper and checking to see whether you are getting them right. So the first one says, log base 9 of 243 is equal to t. We want to change that to index form. So we write our number, 243. It should be equal to the base, which is 9, raised to the power t. Number 2, log base 5 of 200 is equal to b. We want to change that to index form. So remember, the number is 200. That should be equal to the base, which is 5 raised to the power b. So 200 is equal to 5 raised to power b. 3. Log base x of 27 is equal to 9. The number is 27. That should be equal to our base, which is x raised to power 9. So 27 is equal to x raised to power 9. Again, we have log base 5 of q is equal to 2 over 5. So once again, our number is q. That should be equal to our base, which is 5, raised to the power 2 over 5. It doesn't matter whether you have numbers or fractions or whole numbers. The same principle holds. So the next question says log base 4 of 0.25 is equal to z minus 1. So again, the number is 0.25, and that should be equal to our base, which is 4, raised to the power z minus 1. Remember to put the z minus 1 into brackets. Good. Let us now evaluate some expressions in logarithms by first changing them to indices and then solving them using the laws of indices. We'll take 3 examples. The first one says, evaluate log base 10 of 1 million. Now what we do is we let log base 10 of 1 million be equal to x. Then we write this expression in index form, the way we just did. So we have 1 million to be equal to 10 raised to the power x. Then we will write our left-hand side also in index form. So we have 10 raised to the power 6 to be equal to 10 raised to the power x. Now, if you remember in our indices, we said once the two sides are equal and the bases are the same, we can easily equate the exponents. So that gives us x to be equal to 6. And so log base 10 of 1 million is equal to 6. The second question says, evaluate log base 4 of 32. Now we need to solve this. So we are going to write both sides as indices to base 2. On the left-hand side, we have 2 raised to the power 5. And on the right-hand side, we will have 2 raised to the power 2x. Now, since both sides have the same base and are equal, we can easily equate the exponents. So we have 2x to be equal to 5. That gives us x to be equal to 5 over 2, or 2.5. And so we are saying log base 4 of 32 is equal to 2.5. Now the next question says, evaluate log base 125 of 25. So once again, we let log base 125 of 25 be equal to x. We write both sides, or the whole expression, in index form. And that gives us 25 is equal to 125 raised to the power x. Now to solve this, we have to write both sides to base 5. That gives us 5 raised to the power 2 on the left-hand side and 5 raised to the power 3x on the right-hand side. Now that both sides have the same base, we can very conveniently say 3x is equal to 2 and x is equal to 2 over 3. Therefore, the log base 125 of 25 is equal to 2 over 3. Now the next question says log base 1 over 9 of 27. We have to evaluate that. Remember, first thing, we let log base 1 over 9 of 27 to be equal to x. Then we write the expression in index form. So we get 27 to be equal to 1 over 9 raised to the power x. Now, to be able to solve this, we will have to write both sides as indices with the same base. So we change 27 to become 3 raised to the power 3. And then we write the other side as 3 raised to the power negative 2 for 1 over 9 first, all to the power x. Now that gives us, when we equate the powers, 3 to be equal to negative 2x. And we get x to be equal to negative 3 over 2, or negative 1.5. And so log base 1 over 9 of 27 will be equal to negative 1.5. Again, we want to look at log base 10 of 10. So just as we did, we are going to let log base 10 of 10 to be equal to x. Then the next thing, we write the expression in index form. So we get 10 raised to the power x is equal to 10. Now to be able to solve this, we will have to write our 10 on the left-hand side as 10 raised to the power 1. Then now we have two indices, the same base. So we can equate our powers and we get 1 to be equal to x, or x is equal to 1. So we say log base 10 of 10 is equal to 1. Again, we want to look at log base 13 of 13. We want to evaluate that. First thing, let log base 13 of 13 be equal to x. Write it in index form. And you are getting 13 to be equal to 13 raised to the power x. Now the 13 on the left-hand side is the same as 13 raised to the power 1. So we write it as 13 to the power 1. Now that both sides have the same base, we can equate our powers and we get x to be equal to 1. So log base 13 of 13 is equal to 1. Now, I hope you have observed that log base 10 of 10 is 1, log base 13 of 13 is 1, log base 25 of 25 is 1, and log base x of x is equal to 1. Therefore, the log to the base of any number of the same number is always equal to 1. Now, let's look at this. Log base 10 of 1. We want to evaluate log base 10 of 1. So again, let's put log base 10 of 1 to be equal to x. Let's write the expression in index form. We'll get 1 to be equal to 10 raised to the power x. Can we change 1 to an index number with base 10? Yes. We know that 10 raised to the power 0 is 1. So we are going to write the 1 as 10 raised to the power 0. So we have 10 raised to the power 0 to be equal to 10 raised to the power x. So as you can see, x will be equal to 0. So log base 10 of 1 is equal to 0. Again, we want to evaluate log base 15 of 1. Log base 15 of 1. So once again, let's write log base 15 of 1 to be equal to x. Write it in index form. It becomes 1 is equal to 15 raised to the power x. We need to change the 1 to an index number with the base 15. Now you see that 1 can be written as a number with any base. So we are going to write our 1 as 15 raised to the power 0. So we have 15 raised to the power 0 to be equal to 15 raised to the power x. We can equate our powers because the bases are equal. So that gives us x to become 0. Therefore, log to the base 15 of 1 is 0. Again, you would have observed that log base 10 of 1 is 0, log base 15 of 1 is 0, log base 25 of 1 is 0, and log base x of 1 is 0. Therefore, the logarithm to any base of 1 is equal to 0. Well, we have to end it here so soon. You can work more questions from your notes. And I hope you will do that. In this lesson, we have learned how to convert an equation in index form to log form. For instance, we said if k is equal to m raised to the power n, then log base m of k is equal to n. We have also learned how to convert an equation in log form to index form. Finally, we evaluated logarithms by first changing them to indices and then using the laws of indices to solve for the variable. We noted that log base 10 of 10 is 1, log base 13 of 13 is 1, log base x of x is 1. Also, we noted that log base 10 of 1 is 0, log base 15 of 1 is 0, and log base x of 1 is 0. Well, that ends our lesson for today. Make sure you practice. Now, logs have a way of confusing students. So make sure you practice so that the next lesson you will really flow along with me. Well, students, we have come to the end of today's lesson. Keep practicing and join us again for the next lesson where we will learn about the rules of logs. Until then, bye-bye.